qualities of Ramanujan were that he was genius, he was shy and quiet, he was dignified in his field, and was a mathematical genius, along with being intelligent and hardworking. Every year, 22nd December is celebrated as National Mathematics Day to commemorate the birth anniversary of Srinivasa Ramanujan. And today, we are going to know about him. He was born in a poor Brahmin family in a small village of Kumbakonam in Madras Presidency, which is now in Tamil Nadu state. His father was a clerk in a shop. He completed his secondary schooling from the local secondary school and studied in the Government Arts College and Panchayappa's College, from where he hadn't received any degree. But the college from which he received the Bachelor of Arts by Research degree was the Trinity College of Cambridge. He also studied from the Unity of Cambridge, situated out of India. Well, you might be thinking that why he didn't receive any degree from 2 out of his 3 colleges. This is because he was so devoted to mathematics that he wasn't studying well in other subjects, because of which he even failed twice. At the age of 11, he was considered a child prodigy. He had exhausted the knowledge of 2 college students who were a lodger at his home. He later lent a book written by S.L. Loney on advanced trigonometry. He mastered this by the age of 13 while discovering sophisticated theorems on his own. By 14, he received merit certificates and academic rewards that continued throughout his school career and assisted the school in logistics of assigning its 1200 students to its approximately 35 teachers. In 1903, when he was 16, he obtained a library copy of a book named Synopsis of Elementary Results in Pure and Applied Mathematics from a friend. In the consecutive year, he independently developed and investigated the Bernoulli numbers and calculated the Euler-Mascheroni constant up to 15 decimal places. His peers at the time said they rarely understood him and stood in respectful awe of him. This time, he filled many notebooks with his theories and new and amazing evidences. But the main problem was that due to less number of pages, he sometimes used to overwrite on the same page with red ink. And this is the time he started contacting British mathematics, who were studying in the Cambridge University. He drafted letters to renowned British mathematics such as H.F. Baker, E.W. Hobson, E.W. Middlemas, etc. The first 2 persons were H.F. Baker and E.W. Hobson, who ignored his letter, and then he wrote letter to Professor G.H. Hardy on 16th of January 1913. Hardy said that the theorems defeated me completely. I had never seen anything in the least like them before, and they must be true. And then he asked his colleague J.E. Littlewood, who was also amazed by Ramanujan theorem. On 8 February 1913, Hardy replied to this letter by saying that it's essential that I should see proofs of some of your assertions. Ramanujan was happy and he sent a letter packed with theorems, writing, I have found a friend in you who views my labor sympathetically. And then on 17 March 1814, after the request of G.H. Hardy and some other mathematicians, Ramanujan left for England by a ship. There, he went to the Cambridge University and studied with the help of his colleagues. There, his colleagues were G.H. Hardy and G.E. Littlewood. He did many research works with the help of both of his colleagues and made many new formulae. Ramanujan was plagued by health problems throughout his life, which even caused his death. His health worsened in England. Possibly, he was also less resilient due to the difficulty of keeping to the strict dietary requirements of his religions. He was diagnosed by tuberculosis and a severe vitamin deficiency and confined to a sanatorium. After his death, his brother Tirunarayan complied Ramanujan's remaining handwritten notes and it consisted of formulae on singular moduli, hypergeometric series and continued fractions. One of Ramanujan's remarkable capabilities was the rapid solution of problems, illustrated by the following anecdote about an incident narrated by his teacher. He posed a problem to Ramanujan. Imagine that you are on a street with houses marked 1 through n. There is a house in between x such that the sum of the house numbers to the left side of it equals the sum of house numbers to its right. If n is between 50 and 500, what are n and x? This was a bivariate problem with multiple solutions. Ramanujan thought about it and gave the answer with a different twist. He gave a continued fraction as the answer of this question. The unusual part was that it was the solution to the whole such class of problems. His teacher, Mahalanobis, was astounded and asked how he did it. He simply said that the minute I heard the problem, I knew that the answer was a continued fraction. Which continued fraction, I asked myself, and the answer automatically came to my mind. The number 1729 is known as the Hardy-Ramanujan number after a famous visit by Hardy to see Ramanujan at a hospital. He said, I remember once going to see him when he was ill at Putney. I had written in a taxi cab number 1729. I remarked that number to be rather a dull one. But Ramanujan replied, no, it is a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways. Immediately before this anecdote, Hardy quoted Littlewood as saying that every positive integer was Ramanujan's personal friend, and the two ways of expressing were 1 cube plus 12 cube and 9 cube plus 10 cube. Generalizations of this idea have created the notation of taxi cab numbers.